The heart of the plant throbs with the ceaseless rhythm of the state-of-the-art blast furnace. This behemoth, operating 24 by 7, devours a daily diet of 6,000 tons of iron ore, coke, and limestone, transforming them into molten iron at a scorching 4,000 degrees Fahrenheit. Superheated air blasts through the furnace bottom, fueling the chemical reactions that breathe life into molten iron. In a highly automated control room, technicians act as the furnace's maestros, meticulously monitoring and directing its fiery symphony. A robotic arm, a testament to modern ingenuity, periodically drills out a clay plug, unleashing a torrent of molten iron that cascades into waiting, insulated bottle cars, creating a mesmerizing scene of sparks and molten metal. The molten iron, however, isn't quite steel yet. Its journey continues to the basic oxygen furnace, BOF, where the true transformation occurs. Here, the bottle cars disgorge their fiery contents into massive ladles, carefully ferried by overhead cranes. A calculated blend of 25% scrap metal, a byproduct of the region's auto industry, is added to the molten iron. Then, the drama unfolds. Pure oxygen, a tempestuous force, is injected at a staggering 21,000 cubic feet per minute. This molten ballet removes excess carbon, melts the scrap, and births molten steel. The BOF's fiery crucible yields its bounty, a 250-ton ladle brimming with molten steel, ready for the next stage, the Ladle Metallurgy Facility, LMF. At the LMF, precision reigns supreme. Electrodes plunge into the ladle, reigniting the steel and allowing for the addition of specific alloying elements. Here, the steel's destiny is crafted, its chemistry, cleanliness, and temperature meticulously fine-tuned to meet each customer's demands. For some, the next stop might be the vacuum degassing unit, where the steel is exposed to near absolute vacuum, coaxing out impurities and resulting in ultra-low carbon steel with exceptional formability and strength. The spectacle continues at the casting bay, where the ladle travels to a colossal rotating turret continuous caster. The molten steel flows through a protective shroud into a tundish, a temporary holding vessel. From here, it descends into water-cooled copper molds. As the steel confronts this sudden chill, it begins to solidify into a glowing slab 8 inches thick. A fine water mist further cools the slab, and gas torches precisely sever it according to customer specifications. Each glowing slab, a testament to the plant's prowess, is barcoded before embarking on its next leg, the hot mill. The iron and steel industry forms the backbone of modern civilization. From the towering skyscrapers that pierce the clouds to the nimble car chassis navigating city streets, steel is the ubiquitous material that underpins our world. This fundamental industry fuels economic growth by employing millions globally and providing the essential building blocks for countless other goods. Beyond its versatility in shaping everything from appliances to machinery, steel serves as the very foundation of infrastructure development, construction, and manufacturing. While the industry's future remains undeniably strong, it faces pressing challenges. Competition, environmental concerns, and resource depletion necessitate adaptation. Steel producers are at the forefront of innovation, developing technologies to streamline processes, minimize costs, and lessen the environmental footprint of production. The industry's ability to navigate these hurdles will determine its continued reign as a cornerstone of the global economy. The iron ore mining process is the extraction of iron ore from the Earth's crust. It is a complex process that involves several steps, from exploration and discovery to processing and transportation. The first step in the iron ore mining process is to find a deposit of iron ore. This can be done through geological surveys, mapping, and drilling. Once a deposit has been found, it must be evaluated to determine if it is economically viable to mine. This involves assessing the size, grade, and quality of the ore deposit, as well as the costs of mining and processing. The iron ore mining industry is working to improve its sustainability performance. This includes reducing dust and noise emissions, improving water and soil quality, and reducing greenhouse gas emissions. The industry is also developing new technologies to improve the efficiency of mining and processing, and to reduce waste. Once the iron ore has been mined, it must be processed to remove impurities and concentrate the iron content. This process is called beneficiation. There are several different beneficiation methods, but the most common ones are: crushing and screening involves breaking up the ore into smaller pieces and then separating them into different sizes using screens. Grinding involves further breaking down the ore into fine particles. Concentration involves separating the iron ore from the gangue or impurities. This can be done using a variety of methods, including magnetic separation, flotation, and gravity separation. Once the iron ore has been processed, it must be transported to a steel mill. This can be done by truck, train, or ship. A revolutionary transportation solution is poised to unlock billions of tons of iron ore trapped in geographically challenging locations. This system bypasses the need for environmentally destructive deep-water ports, which require massive dredging and significant upfront costs. Instead, transshippers act as the cornerstone of an industry-leading, dust-free transport chain. Fully unclosed autonomous road trains will ferry the iron ore to a dedicated loading facility. Here, the 20,000-ton capacity transshippers take over, boasting an impressive loading rate of 8,000 tons per hour and an unloading rate of 6,000 tons per hour. These behemoths then transport the ore out to sea, where Cape-size vessels wait patiently 40 kilometers offshore. The transshippers are equipped with self-loading systems that meticulously distribute the ore throughout the massive holds of the Cape-size vessels. When discharge is needed, the ore seamlessly flows onto conveyors feeding a loading boom, transferring the valuable resource directly into the waiting bulk carriers. Powering these innovative transshippers are powerful tugs designed with crew comfort in mind. State-of-the-art communication systems keep seafarers connected to loved ones, ensuring a high quality of life even while working remotely. The tugs connect seamlessly to the barges using an articulated tug and barge (ATB) arrangement. This configuration offers superior versatility and reliability, allowing for bespoke features to be incorporated into the design of each transhipper, making